Okay, so as I said today, we want to focus with AC theory. So on the on that chapter 2, it talks about the DC, which is the direct current. So remember, I said on direct current, you'll be dealing with the current that you find which flows in one direction. Okay, so on AC now, we'll be talking about the current which changes the direction now. So we'll be focusing with the current which changes the direction. All right, okay. So mostly on AC, you find it on the supply side, which is a generator. Ne? Remember, you can have a motor, you can have a generator. Whereby I say a motor, it converts from electrical to mechanical, and then we say the generator, it converts from mechanical to electrical. Okay, so this diagram that I just draw there, it's a simple structure of what of a generator. A generator is being built with two. It have two magnets. It have the north pole, and then it have the south pole, and then it have the magnetic flux, which is the force which will be going this way. As we know about the magnetism, whereby if you're having two magnets with different sides, they will attract. So the forces will be coming from this side going to this side, and then you'll be having the shaft between. And then whenever your shaft is rotating, that's when electricity is being produced. Okay, of which I said on chapter 2, that's when you have the parts of a generator or the parts that you can find on a generator and also their functions. So we're simply saying whenever your generator is rotating, it produces an EMF, okay, through what we call a sine wave. So this is the sine wave. So they it have 90 degrees, here to be 0, here to be 360. No, not 360 on this part. This will be 180, not 360.
Mm.
180, and then here will be 360. So we're simply saying whenever your shaft rotates 90 degrees, that's when it produces the highest EMF, which means this will be your maximum EMF, which is the maximum value, ne? Which they can refer it to as a peak value. Is that okay? So
Yes.
please understand on how does your generator operate, or the parts that you find on a generator, how does it produce a voltage? Okay. So as I said, it produces what we call an EMF. Okay. So you have different formulas that you can use to calculate your EMF, which is what they call the instantaneous EMF. So they're saying the first formula to calculate your instantaneous EMF, which is formula number 1, they're saying E is equals to E max sine theta, which means your E max, that will be the maximum voltage that you'll be given. So we're saying it will be the maximum voltage sine at a given angle. Okay. And then if it is an instantaneous current, that's formula number 2. So it can produce also an instantaneous current. How do you find your instantaneous current? It will be the maximum current sine at a given angle, which is sine theta. So there are two formulas to calculate the instantaneous EMF and also to find the instantaneous current. Okay. And then you can also, let's say you are not given, formula number 3, you are not given Emax, which is the maximum EMF. You can calculate the maximum EMF by saying the density multiplied by the length multiplied by the velocity. So that's the formula that you can use to calculate your Emax. That's if it is not given. So you're saying to calculate your Emax, it will be the density, which is measured in Teslas, the length, which is in meters, and also the velocity, which is meters per second.
Okay.
Okay, you can also have another formula that you can use to calculate your Emax. Formula number 4, the saying is 2 pi B A N and small letter n. I was supposed to write E is equals to, the saying E is equals to, which is formula number 4. So we are saying to calculate your Emax, you can also still use these formulas. So which formula are you supposed to use? You're going to be guided with the given information. So we're saying to calculate your Emax, it's going to be 2 pi, the density, the area. So if you check with this part, now you have 2n. So the other one, it will be the number of tens. The number of tens, and then the other one, it will be the speed, which is rev per minute. Okay. So if it is small letter n, it's supposed to be rev per second. And remember, whenever it's big letter n, I said that's when you're given rev per minute. Ne?
Minute.
How do you change ref per minute to ref per second? You divide by 60. So whenever a small letter n, it will be ref per sec. So the one that you use here, it will be ref per second. So that's another formula that you can use to calculate your Emax. Are we okay?
Yes.
All right, okay. And then you can also have the formula to calculate the frequency that it will be operating at. How do you calculate your frequency? It will be NP divided by 6. So to calculate the frequency, which is in hertz, frequency which is measured in hertz, it will be N, which is, if it is big letter N, I said it's ref per minute, and then multiply by P. Your P is, remember, from N3, it's 4 pairs. You know? So whenever you are given number of poles, you are supposed to divide them by 2 to make them 4 pairs. So it's going to be the speed multiplied by the 4 pairs divided by 6. But let's say in another case whereby you are given your speed in ref per second, this formula becomes, so your frequency to be equals to NP, which is just the speed which of ref per second multiplied by 4 pairs. No? Okay, and then formula number 6. You can also be asked to calculate the time. So how do you calculate the time? It will be 1 over f, which is 1 divided by the frequency. And then your time, it will be in seconds. Are we fine, guys?
Yeah, we're fine, sir.
Yes, we are fine.
All right, okay. So if you still remember, I said whenever your generator is rotating, that's when it produces the EMF, meaning it will be rotating at a certain angle. So in order for you to find the EMF, I said it will be the maximum value multiplied by the sine at a given angle. But sometimes you are not given the angle which is in degrees. Ne? They can also give you an angular velocity. So your formula, it can also changes. So I can also have formula number 7, which says E is equals to E max sine of WT. So what will be your W? That will be the angular velocity. How do you calculate your W? It will be 2 pi F. Okay. And please note, W is measured in radians. It's measured in radians, of which we know that if we want to do the calculation, we are supposed to use the angle which is in degrees, because it will be turning at a certain angle in degrees. So hence you are supposed to know how to convert radians to degrees. How do you convert radians to degrees? You multiply by 57, comma 3. So meaning on this formula, I can have this formula. It says E is equals to E. It will be E max sine. Instead of writing W, I can write 2 pi F multiplied by what? By T. And please note, since in order for you to find your EMF, your instantaneous EMF, you will need an angle which is in what? Which is in degrees. Hence, you have to convert this to become in degrees. So hence, you have to multiply by 57, 3. Okay, NB. So please note, I'm saying as long you are not given an angle in degrees, they give you the radians. This formula, you have to multiply by 57, 3. Same thing with this part, you have to multiply by 57, 3. That's if you're not given the angle in degrees, you are given the angular velocity in radians. Is that clear?
Yeah.
Okay, so it's the same thing with I. I can have it to be I. It will be I max sine, open bracket, which is 2 pi F T multiplied by 57, 3. Example, and then we'll write the, remember I said whenever you're answering this, you should write the given information down and then you can answer the question. So I'm just going to read. Okay, so they're saying a simple 4-pole AC generator is driven at 1000 rev per minute. So they're saying a simple 4-pole A simple 4-pole, meaning I'm given the number of what? The number of poles, né? Which is 4. And remember, what did I say about the number of poles? I said you must always divide them by 2 because we always use the pole pairs. So this will be divided by 2,
True.
which
Yeah.
will be equals to 2. Né? Okay, and then you are given the speed, which is rev per minute, which is big letter N.
Yeah.
Okay, of 1,000 rev per minute. Okay, they're saying the rotor has a total of 200 tens. So you're given a number of tens, which is okay. So here, let me just write tens so they won't confuse us. Nah? Because if I write
Mm.
n and then it's gonna confuse us. So you're given the number of tens, which is 200. Okay, they're saying with a wire loop area of 1,600 millimeters squared. So I'm given the area, which is 1,600 millimeter squared. Okay, they're saying the magnetic field has a uniform magnetic flux density. Okay, they gave me the density, which is 1,5 Teslas. Okay, they're saying if the axis of rotation is at a right angle to the direction of the magnetic field, calculate the following. So this is our given information. I'm given number of pole pairs. I'm given the number of the number of the speed, which is the rev per minute. You're given the number of turns. You're given the area, and you're also given the density. So on A, they want you to find the frequency. On A, they want you to find the frequency. Let's see. We said, how do we find the frequency? I said to calculate your frequency, I can use NP divided by 60. Né? Why am I dividing
Yeah.
using the one divided by 60? Because I'm given the rev, which is the rev per minute. Né? So to calculate the frequency,
Mm.
it would be 1,000 multiplied by 2. Oh, my 2. 2 divided by 60. And then you can have your frequency, which is in hertz.
33,33.
Okay, so you're getting is
Comma
33,333
333.
hertz.
Mm. Mm.
Okay, and then after that, this is your A. On B, they want you to find the time. No? I said, how do you find the
Mhm.
time? We said to calculate the time, it will be 1 over 1 over F, no? Which is
Mm.
1 divided by 33,333. So it's 1 divided by 33,33,
0,03.
0,03
Three. Mm.
seconds.
Zero. 0, yeah.
Okay. So I said your time should be in seconds. Huh?
Mm.
Okay. And then on C, they want the maximum value of the EMF. The maximum value of the EMF. So they want you to find the Emax. Huh? And remember that I said there are two formulas that I gave you to calculate the Emax. I said we can use the
Mm.
one which says the density multiplied by the length multiplied by the velocity. But in this case, I'm not given the length, I'm not given the velocity. So I can use the one which says pi, we say 2 pi b, we say 2 pi b a, big letter n and small letter n.
Okay.
Yeah, we can use
Mm.
this one. So because we are given the density, we are given the area, we are given the number of tens, and then remember also I said if it is small letter n, your speed you're supposed to
In.
divide it by 60, but this small letter n meaning your speed should be rev per second. Eh? So
Mm.
meaning we have to divide 1,000 by 60. And the other thing that you should also take note of, check with the area. The area is measured in what? In meters squared. And then this one they gave you millimeter squared. So you're supposed to know how to change from millimeter squared to meter squared. Okay. So remember, if you are having millimeter squared, this squared is what? It's also multiplying this part. And remember, I said milli means what? 10 to the power negative 3. So this is the same I'm having 1600 times 10 to the power negative 3 squared, ne?
Mm-hmm.
Which is the same as 1600 times 10 to the power negative what? Negative 6 meter squared. So I'm simply saying to convert from millimeter squared to meter squared, you multiply by 10 to the power negative 6. Okay, I think we can find our Emax.
0,016.
Okay, let me just put the values here. So we're saying it's 2 pi times the density of 1,5 times the area, which is 1,600 times 10 to the power negative 6 multiplied by 200 and then multiplied by, remember this, the speed we said is 1,000 and then you divide it by what? By 60. You know? You do this and then you find your maximum EMF. Then you're supposed to get 50,265 volts. So that's how you calculate your Emax. And remember, I said you also have a different formula that you can use. So now, which is you're gonna be guided with the given information. And then on D, now they want you to find the instantaneous value 60 degrees after the beginning of the cycle. So they want you to find the instantaneous value which is being produced whenever your shaft it have rotated 60 degrees. Huh? And I said, how do we calculate our E? Since we are given the angle, I'll use E max sine theta, which is same as 50 sine 60. So this one is simple because you are given the angle, which is already in degrees. So it's just a matter of just substituting. Then you get 43,531. Remember, it's an instantaneous EMF. So it'll be in volt. Are we okay? Okay, I believe we are fine. So that's how you can calculate your instantaneous EMF, how you calculate your Emax, the frequency. Okay, someone there. Let me just admit. Okay. So guys, so it's not always the case whereby they'll ask you to calculate the Emax. They'll also ask you to calculate, let's say, the instantaneous value. For example, they can give you the instantaneous value. They can ask you to calculate what? Let's say the time. For example, we said this formula says E is equals to Emax sine 2 pi ft. So they can still even ask you to calculate, say, the time on this equation while they give you E. Ne? So if you just understand the formula, then you won't go wrong. Are we okay? So you can then try these other examples which are there. You can also try those examples. Okay, and then after this, it talks about the average values, how you can calculate the average values, which is the E average, so which is 0,637 Emax, of which I've shown you on how to calculate the Emax. You can also have the I average, which is 0,637 Imax, and then we can also have the RMS values, whereby you can have ERMS, which is 0,707 Emax, you can also have the IRMS, which is the root mean square values, IR 0.707i. IMAX. I believe you guys you have covered this when you're doing your N, because this thing is there at N, is there at N2 and also at N3. Okay, and then if you still remember, you also have the form factor, the crest factor. Oh, sorry about that. Okay, so the same to calculate the form factor, which is the RMS value, which can either be E RMS divided by E, E average. And then you can also have the crest factor, which is I max divided by IRMS. So these are some of the calculations which can also come with this question: how to calculate the average values, how to calculate the RMS values, how to calculate the form factor, and also how to calculate the crest factor. And you should also know how to define the form factor, how to define also the crest factor. So the form factor to be the ratio of the RMS value divided by your average value, and then the crest factor to be the RMS value divided by your IMAX, which can be the Emax divided by your RMS values. Are we okay, guys?
Yes, sir.
Yes, we are fine.
Okay, so there are two ways that you can find your RMS. Remember, I showed you this is how you can use your to calculate the average values or the root mean square values. Ne? So there's another way also, which they call the sinusoidal way, that you can find your values also. Okay, let me just also write it down. So the thing you can calculate. Okay, E1 plus E2 plus E3 plus En. So you're saying we can also use this formula. That's if they gave you what we call the mid-ordinate rules, whereby you are given a number of voltages. So let's say you're given E1, E2, so you just add all the voltages and then divide by the total number that you'll be having. So the same thing, I can have I average. So it will be I1 plus I2 plus I3 plus let's say IN, meaning they can either be 4, they can be 5, they can be 6, it depends. Divide by N. So that's another way that you can calculate your average values. When it comes to root mean square values, you can use, when it's ERMS, now it will be the root of E1 squared plus E2 squared plus E3 squared plus En divided by N. When it's IRMS, it will be I1 squared plus I2 squared plus I3 squared plus let's say IN squared divided by N. So I'm simply saying there are two ways that you can calculate your E average. Either you use this one if you are given the maximum value. If it is not given, they gave you the range, you can use the mid-ordinate rule, which is this, of which I believe you have covered this from N2 and also
And for you.
N3.
Mm.
All right, okay. So that's the first section of your chapter 1, which is unit 3.1. So it talks about how to calculate the instantaneous EMF, how to calculate the Emax, how to calculate the average values, how to calculate the RMS values. Let's say you're given the mid-ordinate rule. What do you do with the mid-ordinate rule? I show you the formulas. Okay. So I believe now you can go through all the examples and also some of the past question papers regarding this, what we have covered. So we are not yet done with the whole topic, but you can still cover on 3.1. Are we okay, my good people?
Yeah, bro. Yes, sir.
Yes, sir, we are good. We are good.
Okay, so any questions before we conclude?